The next question is storage classes. What are storage classes? Storage classes. Storage classes are like this: automatic, register, external, and static. That means automatic, register, external and static. There are 4 types of storage classes. Means I can declare a variable as automatic INTX, or simply if you say INT Y, it is treated as automatic by default. Or I can also say register INT Z, register INT Z. That means X is automatic variable, even Y is also automatic variable, even if it is not specified anything. Then Z is register type variable. Then static, say P, static INT P. So P is static variable, X is automatic, Y is also automatic, not specified, but Z is register, P is static. Now we will see what they mean. These automatic variables, they are stored in memory. Automatic variables stored in memory. That is, for X and Y, the space is allocated inside the memory itself. And one more aspect of automatic variables is they are created and destroyed along with the function itself. For example, I have a function f. Inside that I declared INT X. So this is automatic variable. Now the function is called, code is executed, function exits, returns. So when the function is invoked and function enters here, this is variable is created, automatic variable is created. When the function exists, automatically it is destroyed. So automatic variables are created and destroyed along with the function, and they are stored in memory. Now what is register? This is most of the variables are automatic. Normally by default all variables are automatic unless you specify specially. So what is register variable? Register variable means CPU, that is central processing unit, that the microprocessor has registers inside. Registers, they are memory locations on the processor itself. Whereas memory means computer, there is a memory bank, there is a separate ICs, that is memory. Whereas the memory on the CPU is called registers. So register variable means, for example, Z is a register variable. If you declare a variable as a register, then that variable is stored in the CPU registers. Register INTZ means Z is a register variable and it is stored in CPU, one of the CPU registers. So what is the use of it? If it is on the CPU register, if you want to access the variable, then you can immediately access from the register itself, from the CPU. I don't have to go to the computer memory, which will take some time. So the reason for this is speed. So if the variable is in the CPU registers, then I can quickly access it fast. I don't need much time. Whereas in the memory, I have to go to memory and bring it and bring the data. That will take time, whereas this is fast. So where there is time is critical, very critical, then we use register variable. Then register also, this is also optional, not compulsory. Means even if you declare, say I declared int z as register variable, that doesn't mean that compulsory it will become register variable. The compiler may accept it or reject it. Suppose there are too many register variables, CPU registers are limited. Specified number of registers are there, limited numbers. If all of them are allocated, all the registers are allocated, available registers for variables as register variables, then there is no more registers left. Then even if you ask the compiler, even if you declare a variable as register, the compiler cannot do anything. So it will not be this. So this register is only optional, it's not compulsory. The compiler may reject or accept this. So that is what is register variable. Next, coming to static variable. These static variables, their values are not destroyed along with the function. Suppose there is a function here, I declare static int x and do something. Now when the function is invoked, the variable is created inside the function. Now the function exists, then this is not destroyed. Static variable is not destroyed. This value is maintained. Suppose when the function leaves, exits, the value is 125. Then when the function is called again, second time, then this variable is not created again, it is already existing with the value 125, it can go ahead with that value, it won't be destroyed. Like that, any number of times function can come and exit, but this value is still maintained. Suppose first function call 125 over, second function call say 350, third function call that value is made. So across the function calls the value is maintained. We can have an example program for this to understand what is a static variable. Suppose I have a function f, I have two variables int x, okay, I'll write small things, void f int x is equal to 100, static int y is equal to 500. Then cout x space y end line. So in this function there is a automatic variable x with value 100, a static variable y with value 500. I am displaying both, then I am incrementing both, x plus plus y plus plus. I am incremented both. Now coming to main, I called simply f. Suppose I call it 3 times. I call f 3 times. Let us see what happens. When I call it first time, x is 100, static int y 500. Display both. It means the output is 100, 500. Now both are incremented, so x becomes 101, y becomes 501. Now the function exits, over. It displayed 100, 500, incremented both, x becomes 101, y becomes 501. Again call, again it goes back. Again automatic variable, again it is created with value 100. But static variable, it won't be created again. This step will be skipped second time. So now whatever is already previously existing y value 501, that is taken. So when it is displayed, x value is 100 as usual, it is again create a fresh 100, whereas y value is the previous one, that is 501. So second time it displays x value as usual 100, whereas y value is previous value 501. Third time also x is again created a fresh 100, whereas y is previous one retained, that is 501, again incremented, so 502. Like this. So across the function calls, local variables or automatic variables, they are this x value, it is destroyed every time and again created again every time. So fresh same value. Whereas static variables, they are created first time, then they are not destroyed. Every time their value is retained. So whenever you come back, the previous value is there, so you can increment it or whatever you do. This is the difference of static variables and normal variables. But one more point is, these static variables, when they are created, by default they become 0, initialized. Then the fourth one is external variable class. So it is declared as extern int x, for example. This is extern variable. So what is this? Extern means external. This variable, there are two cases here. One is a variable may be defined in some other file and used in this file. Variable defined in some other file and used in this file. This is one case. Second one, variable used before definition. Variable is defined somewhere down, but I am using it before definition itself. In that case also I use external declaration. Now let us see examples. So external declaration is used when variable is which is defined in some other file but being used in this file, or variable is declared somewhere down the file, but I am using it here itself before definition. So let us see examples how to do this. Now I have file, suppose file1.c. In this, this is the file here, but these are global variables. All these external variables are global variables. Global variables means they are not defined inside any function, they are outside any function. They are global variables. They do not belong to any particular function. Suppose in this file int x, and suppose there is a function which is using this variable, say it is displaying x, is displaying x. So there is a global variable here outside any function, and a function is using in this file. Now there is one more file called file2.c. In this there is another function called f2. It wants to change this. Suppose I want to make x is equal to 500, display it like this. I want to use this variable only, it is not a local variable, same variable. So how do I use this variable in this file? I declare here as extern int x. So this function is using a variable x which is declared here, then it says extern int x, then use it. This is defined here. This is one case of external variable. The other one is suppose I declare a variable int x is equal to 100 here, and using in a function cout x. Now here I have suppose main. I want to use this variable only. Say x is equal to 500 cout x. So this variable is actually global variable, not declared inside any function. It is a global variable but defined somewhere below the main later. But main is using this variable. So but if I directly use x like this, compiler doesn't know what is x, so compiler will complain undefined variable. So that is why I have to say here extern int x. Extern int x means that is defined somewhere down the line. So I am introducing this is a variable, so I am using it. So compiler will go down and search for this variable. It won't complain now. So this is the other case of the external variable.